Hi everyone, welcome back to Coding and Analysis. And in today's video, I'm going to add cross-validation to the random forest regression model to find the predicted health grade of the NFL player. So as we go over cross-validation right here in the notes, cross-validation or CV, especially k-fold cross-validation, allows you to test the model's generalization ability and then train the model on part of the data and test it on a separate fold. This mimics real-world prediction where the model sees new players or new seasons and get a more reliable performance estimate by smoothing out performance variation that might occur from a lucky or unlucky split, and then going to try to avoid data leakage and overfitting. So each prediction is made on data the model has not seen, so the reported performance is a more honest take. And then cross-validation is a method to simulate real-world performance and reduce overfitting risk. So the random forest regression model's performance on the training data shows how well it can fit the data it has seen, while a five-fold cross-validation evaluates how well the model generalizes to unseen data. So what a five-fold cross-validation does is it splits the full data set into five equal-sized parts called folds. It runs a 5 training and testing cycles in each cycle. It uses 4 folds 80% for training and 1 fold 20% for testing. Each fold gets to be the test set exactly once. It systematically rotates through the dataset so that every example is tested once and only once. So, as we talked about, some more accurate portrayal of the data is going to be more randomized. It's not going to be just learning on 80 training split and testing on a 20% split. So let's go look at the function. So we call the function train and predict underscore CV. And then the parameters of this function will be like before, position and features, but we're going to add a CV equals 5. So we're saying cross validation is going to have 5 folds. So we're filtering the data right here to get the position, and then we're making a copy of the data. And then we're preparing the predictor variables, the columns that we talked about in the earlier videos, and the Y, the health grade, will be the target variable. And then we're resetting the index. And then, so we're going to get the random forest regressor, the import from up here, from the beginning. So random forest regressor and k-fold. So we're going to abbreviate this to RF, and we're going to abbreviate the k-fold to KF. So you can see the number of estimators we're keeping as 100, max depth, how much the depth of the model is learning on these trees. It's just going to be a 10. So if you had a large data set, you would probably put it to 20 or 30, but since this data set isn't too large, we're just going to use a max depth of 10, and the random state will be 42. And then k-fold with the KF abbreviation, we're saying number of splits we want to be 5, and we want to shuffle as well, and we want the random state to be 42 as well. And then this is where we're getting our cross-validated predictions with the Y underscore pred. So cross-val predict, which was also imported up at the top. So we're using RF and the X predictor variables and the Y target variable. And we're saying CV is going to cross-validation is going to equal this right here. And then we're getting the cross-validation scores So the mean absolute error score, and we're saying cross-val score, and we're just writing in the same stuff, the random forest regressor, the X and the Y, X predictor variables, Y target variable, and then the K fold. And this is how we're going to score the MAE scores. And then we're going to print out. This is what's going to print out when we run the function. And then we refit on the full data for feature importance. So using the random forest regressor.fit method and using both for the X variable and the Y target variables, or the Y target variable, which would be health grade. So these are all the columns that the model will learn on, and this is the target variable health grade. And then we're just saying we want a data frame that shows the features and the importance of the features like we did before. And then we're going to print it out. And when we run the function, we're storing the predictions here. We're saying our data split will be cross-val, and the predicted health grade will equal to the y pred right here, y underscore pred. And then we're going to return the position data. It's going to be player fantasy position data split, predicted health grade, and the actual health grade, or just health grade. And then these are the feature sets, the X predictor variables. So just so then the random forest regressor, it's age, games, health status, average season games, 2025 age. And then we'll run it, and then we'll add we'll add a new column. We'll add the serious injured for 2023 and 2024 as well, and see what kind of results we get with that. So we're just saying the RBs get it equal to the wide receiver tight end features, quarterback features get equal to the RB features, since there we're using the same columns. And then we're applying the function, and then the position, and then the features, and the parameters up here. And then we're combining and rounding to 0. So on our CSV file, it's going to be running backs first, wide receivers tight end second, and last, the quarterback predictions. And then we're going to save the results. Then this is going to be what the CSV file is going to show. So let's run this. So we have running back, cross-validated. The mean absolute error score is 3.23. So not too far off. 2024 health status, average season games, 2020. So the most important feature importance are the average season games and the 2024 health status. So wide receiver tight end, it scored much better, or a lot better than the running back at 1.89. And it's using average season games, which really it's 38% for both of them. So, and 2023 health status is only 10%, and the rest of them it's 6%, 3%, 1%, 1%. And then we go to the cross-validated mean absolute error, and we get 6.60. So that's the points off from the actual scores. They're not too bad, but not as good as the running backs and wide receivers. And it's still keeping that 2023 health status at 52%. And 2024 health status is only 17, and average season games is only 12%. So I'm going to end it here. In the next video, I'm going to evaluate the R squared and the the MAE score by position, and then look at the results of this CSV file. So like and subscribe, and leave a comment if you want. And always remember to never stop coding, and see y'all in the next video.